Let us now turn to one of the central functions of the warehouse, storage, or more specifically, the buffer function of the warehouse. When we think about storage, the first image that likely comes to mind is exactly what you see in the two pictures on this slide. Long rows of racks filled with pallets and boxes, either accessed manually by forklift trucks or served by automated machinery in high bay warehouses. But the real importance of storage in a logistics system is not just about stacking goods neatly in a building, it's about providing a buffer. And that is absolutely crucial in most supply networks. Why do we need buffers? Let's take a step back and think about why we even store things in the first place. Ideally, in a perfect frictionless world, we wouldn't need to. We would have perfect synchronization between supply and demand. Every product arrives at exactly the right time, in exactly the right quantity, and it is shipped out immediately. This, of course, is the vision behind just-in-time logistics. And in theory, it's beautiful. But reality is different. In practice, variability is everywhere. Customer demand fluctuates, transport lead times vary, suppliers are delayed, machines break down, forecasts are wrong. Storage is what allows us to decouple processes. It creates independence between production and consumption, between inbound and outbound, between one process step and the next. In other words, it absorbs variability. It acts as a buffer, both in terms of time and quantity. Without buffers, any disruption would immediately ripple through the system. Let me give you a simple analogy. Think of storage as the shock absorber in a car. When you drive on a perfectly smooth road, you might not need it. But the moment there's a bump, and there always is, the shock absorber protects the rest of the car from damage. That's what storage does in logistics. In supply networks, buffers appear in many forms. We have inventory buffers, capacity buffers, and time buffers. Warehouses serve all three. They hold inventory, they absorb processing delays, and they provide time for consolidation, quality control, and rerouting. From a systems engineering perspective, this buffering function is what gives the supply system stability. Without it, systems become brittle. A missed delivery slot might halt an entire production line. A truck stuck in traffic might delay hundreds of orders. This is why we often say that warehouses are not waste, they are insurance. Now, of course, buffers come at a cost. Storage takes up space, ties up capital, and requires handling. That's why the goal is not to maximize storage, but to optimize it. And optimization means balancing the cost of holding inventory against the cost of stockouts, disruptions, and underutilized resources. This is one of the reasons why understanding the exact role of storage in your specific system is so important. In e-commerce, fast availability might require larger picking buffers. In manufacturing, decoupling stages may require intermediate storage. In retail, storage may be used for seasonal smoothing. And we should also mention that the storage function is not just about quantity. It also serves qualitative purposes. It enables assortment variety. It allows for value-adding activities like kitting or packaging. It supports service-level differentiation. In the coming slides, we'll look more closely at different types of storage systems and their characteristics. But as we do so, let's always keep in mind that behind every shelf, every bin, and every tote, there is a function, a purpose that relates back to buffering and decoupling in the broader supply system. Now that we understand the importance of storage in general, let's start breaking it down. This slide presents a simplified overview of storage systems. It's a basic classification, but it helps us build a structured understanding. At the top, we have the general term, storage systems. That's our umbrella. Below that, we split storage systems into two major categories: block storage and rack storage. These two categories differ primarily in how they organize goods in space. Block storage is the most basic form. Goods are stored in stacks, usually on pallets, directly on the warehouse floor or on top of one another. It is a low-cost, high-density solution, but comes with major limitations. Access is restricted. It's often last in, first out, and goods at the back or bottom are hard to reach without moving others. And it is high density only when the building isn't very high, because there are limits as to how high you can stack pallets or bins. We'll cover block storage in detail on the next slide. Rack storage, on the other hand, uses racking systems to store goods in a more structured way. Racks can be shelf racks, pallet racks, flow racks, or other variants. The key idea is that each storage location can be individually accessed. This increases selectivity and accessibility, but usually at the cost of space efficiency. Now, both block and rack storage can be operated either manually or automatically. This gives us four general types: manual block storage, automatic block storage, manual rack storage, automatic rack storage. Let's walk through each briefly. Manual block storage is the simplest. Think of a warehouse with pallets stacked on the floor, accessed by forklifts. This is common in bulk storage or seasonal overflow areas. Automatic block storage is traditionally less common, but is becoming increasingly common, most notably in systems like AutoStore, which technically is a form of block storage accessed by robots from above. More on that soon. Manual rack storage is widespread. This includes everything from supermarket shelves to industrial racking accessed by pickers or forklifts. It offers better organization but depends heavily on human labor. Automatic rack storage includes high bay warehouses with stacker cranes, shuttle systems, or mini-load systems. Let's now take a closer look at block storage. As we mentioned earlier, this is the simplest and often most space-efficient type of storage, but it comes with important trade-offs. Start by looking at the photo on the left. What you see is a typical block storage warehouse. Goods are stored on pallets, placed directly on the ground, and stacked on top of each other, usually up to the stability limit of the load or the safety regulations of the facility. This kind of storage is often used for homogeneous goods, meaning the same item stored in bulk, and for goods that don't require individual selectivity. Examples include beverages, construction materials, packaging supplies, or promotional articles. If your operation requires fast, random access to many SKUs, then rack systems are usually the better choice. The layout is straightforward. You have blocks or lanes of pallets, and the space in between is used for access. The more tightly you pack the goods, the more storage density you achieve, but at the expense of accessibility. Block storage typically works on a last-in, first-out principle. That is, the last pallet placed in a block is the first one that can be retrieved. If you need something from the back, you may have to move several others first. This is a key limitation. Now, on the right side of the slide, you see two diagrams, a cross-section and a top view. These help us formalize what's going on in terms of layout planning. The key variables are CX, pile length, how many pallets deep you go in a block, SI, stacking height, how many pallets you stack vertically, TZ, block width, the number of pallets placed side by side. These dimensions help calculate the capacity of a block storage area. They also influence handling time and required equipment. For instance, deeper stacks may require long-reach forklifts or create safety concerns if stability is poor. One important thing to mention here is fire safety. Block storage can be problematic in terms of fire zones and sprinkler coverage. You need to ensure that your layout complies with local fire regulations, which often means limiting stack height or creating fire breaks. Now, let's talk about modern developments. At the bottom left of the slide, you see an illustration of the AutoStore system. Despite being fully automated, AutoStore is based on the block storage principle. It creates a dense cube of bins, stacked directly on top of one another, and uses robots on top of the grid to access the bins from above. This is a great example of how a traditional storage concept, block storage, can be reimagined through automation and digital control. The core idea remains: maximize space efficiency by stacking units tightly. But now we remove the limitations of physical access by using robots. As a logistics engineer, your job is to understand when block storage is appropriate and how to design it safely and efficiently. Think in terms of layout, equipment, process flow, and compatibility with IT and automation systems.